Hey everybody, Matt Morgan here. In this video, we're going to learn about naming polyatomic ions from Chapter 2 in the OpenStax textbook. We will review the polyatomic ions in Table 2.5. Look at other online references that may help with you naming those polyatomic ions. Then we'll go over some naming trends so you can memorize less and understand more where the names come from. Here is Table 2-5. These are the polyatomic ions you need to learn for this course. You will need to know the name, formula, and charge for these ions. There will be questions on the quiz, midterm, and final, so you do need to know these. One way to learn them is to use flashcards. Other websites like Khan Academy and Tyler DeWitt may be good resources for learning these ions as well, but don't purely rely on these websites because they may include ions that you don't have to memorize or leave out ions that you do. Master list for this course is Table 2.5. Also, in watching my videos, you don't have to see my hands. So is Table 2.5 merely a list of unrelated names? Fortunately not. There are trends that will allow you to know all of these ions without having to separately and independently memorize each one. You will have to memorize some because each trend has a starting point. The first few trends we will talk about involve oxygen. The first trend is ions ending in ATE have more oxygens than ions ending in ITE. Nitrate is NO3 minus, while nitrite is NO2 minus. Note that both ions have the same charge. Same with sulfate, SO4 2 minus, while sulfite is SO3 2 minus. Once again, these both have the same charge. Now let's look at the ClO series. There are 4 ions, ClO minus through ClO4 minus. The ATE and ITE trends help here as well. Let's start with chlorate, ClO3 minus. Chlorite must be ClO2 minus. ITE has 1 oxygen less than ATE. Note that all of the ClO series have a -1 charge. If chlorite is ClO2 minus, what do we call ClO minus? Think about the word hypothermic, which means we don't have enough heat. ClO minus is then, based on this, hypochlorite. Chlorate is ClO3 minus. What do we call ClO4 minus? We're not thinking hypo, but rather hyper, like a hyperactive child having extra energy. We will leave out the HY, but call ClO4 minus perchlorate. Let's review. We start with chlorate, ClO3 minus. 1 fewer oxygen is chlorite, ClO2 minus. Hypothermic chlorite is hypochlorite, ClO minus. Hyperoxygenated chlorate is perchlorate, ClO4 minus. Here they are in order. Hypochlorite, chlorite, chlorate, and perchlorate. Still some memorization here, but the trends should help. Look at these polyatomic ions. They are all pre-existing polyatomic ions with a hydrogen atom in front. Most of the time, hydrogen makes an ion that has a -1 charge. So what you do is start with the polyatomic ion, add hydrogen to the name, then add a +1 charge to it. Carbonate, CO3 2 minus, hydrogen carbonate is HCO3 minus. We know sulfate is SO4 2 minus, so hydrogen sulfate is HSO4 minus. Phosphate, PO4 3 minus, hydrogen phosphate, HPO4 2 minus. What about dihydrogen phosphate? 2 hydrogens, and overall -1 charge, H2PO4 minus. How about bicarbonate and bisulfate? Those are legacy names from older systems. You still see them around, so it's good to be able to recognize them. However, they will not be tested in this class. So to wrap up, there still is some memorization. I don't have any tricks or trends for a polyatomic ion like acetate. For those, pull out the flashcards. The good news is knowing the trends reduces the amount of rote memorization you have to do. You will need to know these ions. As always, if you have questions, contact me via email. You're always welcome to come to the online office hours on Tuesday and Thursday morning. The link is right there. It's the Blackboard Collaborate Lab in our Blackboard. And you can also make an appointment if our office hour times do not work for you.